Hi, this is Miss Benson with SanfordFlipMath, and I'm going to talk to you about section 7.4 in the Springboard textbook on solving quadratic inequalities. So this is something that we've already covered in class, so this is meant as a review from what we've done before, okay? So the first thing to keep in mind is that with an inequality, we're finding not only one value, but a range of values, okay, that will make this true. So what we want to do is find something that is going to make this true, okay? The first thing to do is that we need to find our boundaries, okay? So the way we do that is to set it equal to 0 in this case, rather than having the less than or equal to sign. Okay, so what we're going to do here is we have our x squared minus 3x minus 4 is, I just told you that we have to make it equal to, and I didn't do that. Okay, equal to 0. Now to solve this, we're going to find our factors of 4 and sum them. So we got 1 and 4, we got 2 and 2. Since this value is negative, that means we're going to have different signs. And since this one's negative, that means the big one is negative. Okay, so we got our negative 4. Neither one's different. Well, that's good because if we add negative 4 and 1, we get our negative 3, which is what we're looking for here. Okay, so knowing that, we're going to go ahead and make our box. I'm going to move it down just a tad bit so I can fit my factors in there. Okay, so we have our x squared minus 4, then our factors are x, or 1x, but however you'd like to write that in, I'll add in the 1, and negative 4x. Okay, so finding our factors of this column here, we have an x, factors of this one here, we have a, let's see, I think that's going to be a 1. We'll come back to see if we need to add a negative or not. Factors of this box here, or this row here, is an x, and this one here is a negative 4. All right, so now do we need to add in another negative? Well, this one times this one gives us a negative 4x, and negative 4 times 1 gives us our negative 4. So that's exactly what we're looking for. Okay, so now we need to rewrite this to show that our factors are equal to 0. So we have our x minus 1, or x plus 1, sorry. That little, that's not meant to be a minus sign up there. Okay, so we have our x plus 1 and our x minus 4 is equal to 0. So if this is going to be equal to 0, we have to set each piece equal to 0, so each factor equal to 0, because one of them or the other of them is going to equal 0 at the same time. You can go back to the section 7.3 video if you need a review of why that is. But for now, we'll go forward with this, but please, if you're not sure why, go back to that video from before. Okay, so x plus 1 equals 0. That means we're going to get x equals negative 1 when we subtract 1 from both sides, and x equals 4. We'll keep that or in there, or x equals 4 when we add 4 to both sides. Okay, so these are our boundaries, because remember, we're not solving we did have to solve our equation, but that was only one piece of it, because what we're looking for is to solve the inequality. Okay, so that means we need to first, before I do anything else, graph them on this number line. Okay, so we got our negative, I'm going to put on our 1, 2, 3, 4, add in a couple numbers there. Now our boundaries are negative 1, so I'm going to draw a circle around my negative 1, or positive 4. So I'm going to draw a circle around 4. Now how do we know, do those circles stay circles, or do they become filled in? Now this should be some review from before, so we're going to look back up to the top, and our inequality here, whoops, let's see here. Okay, our inequality here says less than or equal to 0. Therefore, anything that's equal to, so the values that we found down here these values, make it equal to 0. Okay, so make equation true when equals 0. So those have to be included in our solutions because they also make this true because it's part of it is equaling 0. So we're going to fill those in to show that. And again, this should be a review, but we're just going to take a little bit of time with that. Okay, now if we go, now the next thing we need to do are test points in each region. Okay, so I'm going to start out by doing it in a quantitative way. So I'm going to just plug in numbers into that initial inequality. And if, and then we'll go back to the little bit more qualitative way with just pluses and minuses that we did in class. Okay, so I'm going to pick, so in order to pick points, I need to have my initial inequality. So again, this is up at the top, my x squared minus 3x minus 4. X squared minus 3x minus 4 is less than or equal to 0. Okay, so I need to pick a point in this region, and in this region. And the regions are, so the boundary to the left, from boundary to boundary, okay, so somewhere in there, and boundary to the right. So I have 1, 2, 3 regions that I'm picking points from. Okay, so I'm going to pick x equals -2 from that left area. Okay, so I need to plug in my -2. Now don't forget parentheses. I'm going to put these in red because they're so important. Because if you forget them, then you won't necessarily be correct, because if you're squaring the number -2, then that's very different than the negative of 2 squared. Okay, so we're going to have then 3 times our -2 minus 4 is less than or equal to 0. Let's see. So we have -2 squared is our 4 minus -6 minus 4. Again, okay, so if we have 4, this is going to be plus 6. So it's our 10 minus 4. And so we have 10 minus 4 is equal to, so is 6 less than or equal to 0? No. So we're going to, this is not correct. So we're going to go up here, and no, we're not going to shade that region. Okay? Another point, I'm going to pick one in the middle. All right, I'm going to pick x equals 2, or x equals 0, I should say. That'll be in the middle. Okay, so if I have 0 squared minus 3 times 0 minus 4 is less than or equal to 0. Okay, so this is going to be 0. So 0 minus 0 minus 4, that's a -4, is less than or equal to 0. Is that true? Yes, absolutely. So this is good. We like that. So we're going to go up here and shade this region in, because I picked one point in the entire region and it worked. So that means I can shade it. Okay? Now we're going to pick one point again to the right. So we need to pick to the right of 4. So I'm going to pick x equals 5. So I'm going to plug in it. And remember, I'm plugging this into my original equation here. Okay, or my original inequality to find out if that's true. So my 5 squared minus 3 times 5 minus 4 is less than or equal to 0. Now, is that true? So we have a 25 minus a 15 minus 4 less than or equal to 0. Well, I got 25 minus 15 is 10 minus 4 is 6. It's less than or equal to 0. Now, is that true? No. So again, we cannot shade this region over here. So that blue shaded region is your answer. Okay, that is the answer to your graph. That's what you want to show on your graph. Now, if that's true, then we need to go to the and write what x, our solution then. Write it using our x's to show what that is. So if we have our x and our boundaries were -1 and 4, well, that shaded region shows us that the x's were, that -1 was less than or equal to x, which is less than or equal to 4, or that all of the x values between -1 and 4, including negative 1 and 4, are solutions. They're values that make our original inequality true. Okay. Now this method of testing our points was a lot different than what we did in class. It uses some numbers instead of our pluses and minuses. So I'm gonna stop here for right now just so I can get to my next example, and then we're gonna use the pluses and minuses there. But if this way of checking makes more sense to you, please continue to do this. Okay, whatever makes more sense to you, please do that. All right, so now looking at this next inequality. Okay, now the first thing that we need to do, again, is to find boundaries. Okay, so we're trying to find out what values make this inequality true, but in order to do that, we have to figure out where they start and stop, where those values start and stop. So we have our 5x squared minus 13x minus 6 equals 0. Okay, now here we're going to do our negative, and so our a times c, and find factors of a times c. So we have factors of negative 30. Okay, and we're going to find the sum of them. Now let's see. Now what is this telling us here? So this negative, again, is telling us that we have different signs. And this negative here is the big one is negative, similar to the other one. Okay, so our factors of 1 and 30, 1 and negative 30, 2, negative 15, 3, negative 10, and we're going to have 5, negative 6. Now, which one of those add up to negative 13? I got this one. I hope you did the same. You did also. So now we're going to make our box to figure out what our factors are and what this inequality is going to factor into. Okay, so we have our 5x squared, negative 6. One of our factors is 2, so we write 2x, then negative 15x. Okay, so now we're going to find the factor of this column here. Okay, so factor of 5x squared and negative 15x, I got a 5x. Factor of 2x and negative 6, I got a 2. Factor over from this row, 5x squared and 2x, I got an x. And factor here, I got a negative 3. Okay. All right. So now I need to go and write these down as my factors being multiplied together equal to 0. Okay, so my 5x plus 2 is one of my factors, x minus 3 is another, setting them equal to 0. Now just like before and just like in previous videos, we're going to set then each one of these equal to 0 to find the two solutions that are possible. And again, here's this big or in the middle, because it can only be one or the other. X cannot equal both at the same time. So I'm going to do my 5x equals negative 2. For those of you who can do this in one step, that's just fine. Negative 2/5, or x equals 3. Okay, that went kind of crazy there. Okay, our x equals 3. Okay, and again, this is an or. Now these, remember, we're not done because we're dealing with an inequality. We did solve our equation by factoring, but because our original problem is dealing with an inequality, we have more steps to do. Okay, these are just our boundary points. Okay. So we have, let's see, start 2, negative 1, 0, 1, 2, 3, 4. There's my 3. Those lines get bigger every time. Okay, so negative 2/5 is going to be somewhere in between, a little bit less than a half, halfway between 0 and 1, and x equals 3. Now again, let's look up at our original inequality to see, are those circles going to stay open or are they going to get filled in? Okay, now this here is telling us that. So we want to find the values that satisfy this inequality and make it true. So if the values have to be greater than 0, that means, first of all, they need to be positive. And can they equal 0? So can those values that we found make that left side, so make this part equal to 0? Can those be included in our solution when we're graphing it? No. So we're going to leave them open, leave them wide, leave them open because they're not part of our solution. Okay? Now this piece I'm going to work through the other method of testing points to give us another option, just so that this is the one we did in class. So if this is the option you like better, you can review it. Okay? So what I'm looking at is if we have two factors of 5x plus 2 and x minus 3 equaling, and we want it to be greater than 0, that means we want it to be positive. We already decided that. Okay, so just like if one of our factors is equal to 0, then that makes it, so in order for that to be positive, okay, because greater than 0 is positive, that means that when we multiply these two numbers together, it has to give us a positive number. So how do we get a positive number? There's a couple combinations. So if we multiply a positive and a positive together, then we get a positive number, and we're looking for that. We want that. Okay. Now if we get a positive and a negative number, that's going to give us a negative value, not what we want. So I'm going to add parentheses there. So we don't want a combination of factors of values for our factors that is going to give us a negative number. Okay? If we get a negative and a negative, we're okay with that. That's also going to give us a positive. Oops, that's kind of a funky looking positive. Okay. That's also going to give us a positive value, which is also what we want. So what I mean by our, factors that are going to be positive and positive, or positive and negative, what we're going to do is look at, so just the same type of regions that we looked at before. So to the left of our boundary, in the middle of our two boundaries, and to the right of our far right boundary, we are going to test, we want test points, okay? But instead of testing specific points, because I really don't want to have to plug a bunch of numbers into and square it, then multiply by 5, multiply numbers by 13, all that stuff's just weird. I really don't want to do all of that. So I'm going to do it in a little more qualitative way. So this is more like what we did in class, in order to find out which section of our number line each factor is going to be positive or negative, and then we're going to find the combination of those positive and negative values for our factors to figure out which parts we want to shade. Okay? So we'll see if we can tease that out as we get going here. So we have a 5x plus 2, and our x minus 3 here are going to be our two factors. So if we have, let's say, x's, so a value that's to the left or less than my left boundary here, I'm going to say x is equal to negative 1,000. Okay, so a big negative number, I'm just going to call that a big negative number. I'm being specific here so we can use it. But a big negative number times 5 is going to be a really big negative number. Adding 2 to it isn't going to do a whole lot. So that means this region, that whole part of the number line that we're talking about, if we plug any of these values into that factor, we're going to get a negative number. Okay? Now let's talk about where in the middle of these two values. Now I really like using zeros, and 0 is really close, but it's still in the middle because it's greater than my negative 2/5 and it's less than my x equals 3. or it's and it's greater than, or sorry, I'll reword that. So 0 is greater than negative 2/5, and it's also less than 3. So it's still in the middle. I can use that. So if I plug 0 in for x in this factor, so 5 times 0, 0 plus 2, that is going to give me a positive value. So that means every other value in the middle of those two boundaries is also going to give me, that factor is going to be positive if we plug any of the values in between negative 2/5 and 3. Okay? Now, if we look to the right of 3, so something greater than 3, so I'm going to say maybe x equals positive 1,000, or if you want to think of a really big positive number, and I multiply that by 5, it's still going to be really, really positive. Add 2, again, it's going to be positive. So we're going to go, rewrite that in green. So all the values greater than 3 are going to give us a value for our factor of 5x plus 2 that is positive. Okay? Now we're going to go back to our x minus 3. So if we plug a really big negative number, we're going to do the same process. So we plug a really big negative number of negative 1,000 into x minus 3, we're going to get an even bigger negative number. So that, all the values less than negative 2/5 is going to give us a negative value for this factor. Okay? Now, for x equals 0, if we have 0 minus 3, that's also going to give us a negative value, because 0 minus 3 is negative 3. All the values in the middle of the two boundaries is going to give us a negative value for that factor. Looking to our really big positive numbers, so if I have a really big positive number, anything bigger than 3, and I subtract 3, that value is also going to be positive. Okay, so let's look again down here. So I'm gonna, this is where this comes in handy already. So what I was looking for was, I want my factors to combine so that they are both positive at the same time. Well, they're in the same, so if you plug in the same value up here in this region, so at the same time, they're both going to be negative. Is that something that was okay? Yeah, we saw that. That was something that was good, that we wanted to see. So that means that part of the number line is going to be shaded. Okay, because that, any of those values are going to make our inequality true. Okay, now that also happened over here, because we had a positive value times a positive value. For any of the values greater than 3, we were going to have, both factors were going to be greater than 3, so they'd multiply to give us a positive number. So that's looking at, or if we're looking at this one here, okay, that worked. How about in the middle? We found that negative one here that we didn't want. I know it's in green, it's not really the right color. I guess if I do black, that's better than green. Okay, that's not what we want. So we're not going to shade this here. Okay, so that is our solution to our graph. Okay, now we still have to write our actual solution. So what x is greater than or equal to, or in this case, it's just going to be all the values that make this true. Okay, so if we have, so our boundary is at negative 2/5, and all x values less than negative 2/5 makes this true. So x is less than negative 2/5. Can it be equal to? No, because this is an open circle, it's not included. Okay, how about over here? So all the values greater than 3 make it true. So x is greater than 3 also makes it true. Okay, now this has to be a big or in between. Now this can't be written as an and or together like we did the previous one, because of the fact that they are not combined. They're not in the same area. They're going in two different, you're shading in two different directions. Okay, so that's why it can't be written as the one statement like before. Okay, so those are just a couple of examples of solving quadratic inequalities. There's a lot of steps in there, so I know this is a little bit of a long video, but do your best to try these. This is just some review, and thanks for watching. We'll see you later. Bye.